Hi, it's Mr. Krieger. This is going to be the second lesson on circles, other angle relationships in circles. Make sure you print up the lesson. It's 5 pages. Okay, so one of the things that we're going to look at, well, before we look at that, I want to show you something. Let's review. A central angle is what compared to the intercepted arc? It's equal to the intercepted arc. So just to refresh your memory, a central angle looks like this, where the angle is in the center, and the angle itself is equal in measure to this arc. So central, same. So a good way to remember this angle is equal to that arc. An inscribed angle is half of the intercepted arc. So here we see an inscribed angle. In the case of an inscribed angle, the angle touches a part of the circle. The vertex actually touches the circle. And what we know is that the angle is half the arc. So here's the central angle where the vertex is in the center. Angle is equal to the arc. Here's an inscribed angle. The angle touches the circle, and the angle is half of the arc. Okay? So now we're going to take a look at a new scenario. Here we have a situation where we have two chords. AB and CD intersect at point E. What type of angles are formed at point E? Well, we see that these two angles are vertical angles, and these two angles are vertical angles, right? So we see vertical angles there. Okay, but what we want to notice is that the angles all around here are not central angles and they're not inscribed angles, and here's the primary reason why. They are not central angles because the vertex is not at the center of the circle. The vertex is not at the center of the circle. I'll say circle's center. Okay? So, and the vertex doesn't touch the circumference of the circle, so the vertex is inside the circle, but it's not at the center and it's not touching the circle. So this is a new scenario, and this is the angular relationship that exists. I want you to notice I darkened these two arcs. They're related to each other. You'll see two vertical angles here on each side of E. Well, those two angles are going to be related to those two arcs. So what I want you to notice is that arc AC and arc DB are across from the vertical angles. And when I say across from them, I mean if you take this angle AEC, this arc is across from that angle, and the vertical angle from AEC is DEB, and this arc is across from that angle. Okay, and something similar is happening over here. You see that in this case, AED is across from arc AD, and angle CEB is across from arc CB. Notice that angle AEC in this case and angle DEB are vertical angles, which makes them equal. The same is true for angle AED here and angle CEB here on this side. But here's the formula so you know the relationship between the angles and those arcs. The formula when you have two intersecting chords is the following. The angle measure is equal to both arcs added together divided by 2. Essentially, you're taking the average of the arcs. So you add these two arcs together and divide by 2, and you get the measure of those two angles. Remember, those two angles are equal because they're vertical. Same thing here. If you add up arc BC and arc AD and divide by 2, you're going to get the two angles here and here. Okay? So let's try a problem with this. In the diagram below, arc AC is 30. I'm going to put a 30 here. Arc DB is 70. And we want to find the measure of angle AEC. I'll put a little X inside here to represent that angle right there. So as we learn, the angle is equal to the arc plus arc, the two arcs across from each other, divided by 2. Those two arcs are across from each other. So we get the measure of angle AEC is equal to 30 plus 70 divided by 2. 100 divided by 2 is 50 degrees. So that angle AEC is 50 degrees, but so is angle DEB, because those are vertical angles. So that's how you would do this type of problem. Let's go take a look at the next page. Okay, so you could try this problem on your own, pause the video, and then you can check to see if you got it right. All right, so in the diagram, arc AD is 80. I'll put an 80 here. And arc CB is 150. And we want to find the measure of angle CEB, so that's right in here on this side. So as we know, the angle is equal to arc plus arc divided by 2. So the measure of angle CEB is equal to 80 plus 150 divided by 2, which is 230 divided by 2, and that gives you 115. 115. Okay? All right, now, similar question, but we're going to change things around a little bit. Watch this. What if you're given an angle and an arc? See what I mean when we do this problem. Angle AED is 100. That's this angle right here, AED. Arc AD is 70. I'm going to have to squeeze it in right there. That arc AD, I'll highlight it in yellow. This arc here is 70 degrees. And we want to find the measure of arc CB on this side. So let's write down our formula. We know the angle is equal to the arc plus the arc divided by 2. So in our case, this time we know the angle, it's 100. 100 is equal to the arc 70 plus the missing arc x divided by 2. Now we have an equation. Put the 100 over 1. You know how to cross multiply. I'm going to do that over here. You get 70 plus x times 1 is 70 plus x. And 100 times 2 is 200. Subtracting 70 from both sides, we get x equals 130 degrees. So basically arc CB, the measure of arc CB is 130 degrees. That arc right here. Okay? So this is a similar question. Pause the video, try it yourself. I'm going to do it and you can check your work. Okay, angle QPM is 105. This angle here is 105. Arc LN is 40. And we want to find the measure of arc QM. Using the same formula, the angle is equal to the sum of the arcs divided by 2. We get 105 equals 40 plus x over 2. If we put this over 1, we could cross multiply this. 40 plus x equals 210 minus 40 from both sides, and we get x equals 170. This arc here is 170 degrees. All right, it's pretty easy. All right, let's go take a look at the next page. All right, so here we have a scenario where you don't have a diagram. So this will be an opportunity for you to see if you can draw the diagram properly. Why don't you try to see if you can draw the diagram properly? I'm going to do it. Okay, so we have a circle, and the chords LM and NQ intersect at point P. Now this is probably not going to be drawn to scale, but it doesn't matter. It just gives you the idea. So I'm drawing LM. Now L is one end of the chord, M is the other end of the chord. You have chord NQ. N is one end of the chord and Q is the other end of the chord. And they intersect at point P. That means this point right here, put a P there, okay? Now it says if LN, arc LN is 25 degrees and arc QM is 170 degrees, what's the measure of angle QPM, which is right there? All right, so once you got the diagram set up, it's really easy to solve. This is one of the easier scenarios that we saw first. We know the angle is equal to the arc plus the arc divided by 2. In this case, we don't know the angle. We're looking for angle QPM, and that's equal to 25 plus 170 over 2, which is 195 over 2. And we get the value is 97.5. So the measure of angle QPM is 97.5. Okay? All right, so now what we're going to take a look at is two new parts of a circle that you need to know to do the next set of problems. And they're important definitions anyway. So anyway, a tangent to a circle is a line that touches the circle at only one point. Okay, I'll show you the example here. This line is a tangent line. It just touches the circle on the outside. It literally just lays up against the circle and it touches it. It never goes inside. You can't say this is a tangent line because it touches the circle once. Because a line literally means going on forever. If this line went on forever, it would hit the circle again. So only this line is the tangent line. So that's the definition of a tangent line. Now we're going to define a new line called the secant line. A secant line is a line that touches the circle at 2 points. So I'll show you the example here. This is a secant line. It goes through the circle like a chord, but it extends past the circle. So the difference between a chord and a chord would start here and stop here. A secant continues outside the circle. So that's a secant line. So that's how we define these two terms, tangent line and secant line. So a tangent line just touches a circle at the outside. Here's an example where two tangents touching from the same external point are touching the circle. All right, so we're going to define this point. This point P is called an exterior point because it is outside of the circle. So point P is out of the circle. Now, every example that we've had so far, the angles were inside the circle. Now we have an angle outside the circle, but yet the lines somehow touch the circle, so they're related to the circle. So we want to now see if there's a relationship that relates the angle here with those arcs, and there is. And this is how it works. The measure of this angle is equal to the measure of the major arc, the bigger one here. In fact, let me use a couple of colors here. So the major arc will be the bigger one further away from the angle. That's major arc AB. And then we're going to subtract off the minor arc, which is the one that's inside, closer to the angle, because that's a smaller arc. That's less than half of a circle. So it's the major arc, the bigger arc, minus the smaller arc divided by 2. That's what the measure of this angle is going to be. As you can see, it's a simple computation. You just have to remember that if the angle's outside the circle, instead of adding together the arcs, you're going to be subtracting the arcs. All right, so let's try a problem here. In the diagram, we have the major arc is 250 degrees and the minor arc is 110 degrees. So what's the measure of this angle? So using this formula, major arc minus minor arc, we're going to do the bigger arc minus the smaller arc divided by 2, just like in the previous formula, but this time we're subtracting, and it has to be the bigger minus the smaller. We don't want any negative numbers here. That's going to give us 140 divided by 2. Therefore, the measure of angle P is 70 degrees. Okay? Now, there was something interesting about this problem. We didn't really need to be given both these numbers. If we were given 250 was the major arc, then this arc would have had to have been 110 because there's only 2 arcs and the arcs of a circle have to add up to 360. So using that concept, and that idea is right here, let's see if we could do this problem. You might want to pause the video, try it yourself. It says the minor arc is 80. We want to find the measure of angle P right here. We weren't given this arc, but so what? We could do 360 minus 80 gives us 280. That means this arc right here is 280, and now we can do the same formula. The measure of angle P is the major arc minus the minor arc over 2. So the measure of angle P is equal to 280 minus 80 over 2, 200 over 2. So we get the measure of angle P is 100 degrees. Okay, so pretty easy, right? All right, let's go take a look. There's more practice here. Oh, actually, this is a similar but yet slightly different concept. We saw what happens with two tangents in the arc. Let's see what happens with two secants and the arcs. Notice when we have two secants drawn, okay, there's actually 4 arcs, but we're not interested in all 4 arcs. We're actually only interested in the arcs that are in between the two lines. So what I want you to notice is you see the arc AB here? Ignore it. The arc outside is irrelevant. You see the arc CD here? Irrelevant. I'm going to cover that up. This arc right here is irrelevant. The arcs we care about are those arcs in there, okay? I'll actually write it in the smaller. So there's an arc here that we care about, and there's an arc here that we care about. These arcs are outside our lines. In other words, we want the angle created by the lines and the arcs inside the angle. So you see the arcs that I mentioned. Just like before, this is going to be the bigger arc. The arc that's further away is the bigger arc, and this is going to be the smaller arc. And here's the formula. The measure of this angle, I'll call it P, or although it could be called anything. The measure of this exterior angle is the large arc, you know, the one further away, minus the small arc here, divided by 2. It's just basically the same formula, with the difference being that here it's more than just 2 arcs. There are 4 arcs, but this arc is not relevant and this arc is not relevant. Only the arcs inside those lines are relevant. So now let's try a problem. I'm going to redraw a diagram here. Okay, and I'll put A, B, C, D. I don't really need the O there, but I'll put P here. And here's what we know. Arc AC is 70. Arc BD, that's the one in here, that's 42. I don't know how well you can see that. And we want to find the measure of angle P. Using this formula, it's going to be, so the measure of angle P, I'll write that, is equal to the large arc, which is the 70, minus the small arc, which is 42, divided by 2. So what do we get? That's 28 divided by 2, which is 14. So the measure of angle P is 14 degrees. Okay? You can also find the measure of a missing intercepted arc if you are provided with one of the intercepted arcs and the measure of angle P. Let me show you what I mean. In the diagram below, arc AC is 90 and the measure of angle P is 25. And we want to find the measure of arc BD. Well, we could still use this formula, but we're just going to put different things in. So let me write that out. So the measure of the angle is equal to the larger arc minus the small arc divided by 2. So the angle in our case is 25. The large arc is 90. The small arc we don't know, so we'll just call that x over 2. We could put this in over 1 and we can now cross multiply. 90 minus x times 1 is 90 minus x. 25 times 2 is 50. Watch what happens here. This is interesting. It's not difficult, but you might say, I got to subtract 50 because if I subtract 90, I'm going to get a negative number. That's okay. Watch what happens when we subtract 90. We're going to get negative 40 here. Now, normally in geometry, we don't like negative numbers. We don't want negative numbers. But look what happened here. The negative x stayed. So this is actually a negative x on this side. I don't want negative x, I want positive x. So if I divide both sides by negative 1, I actually get a positive answer, even though this was originally negative, because the x was also negative. By dividing by negative 1, we get the positive answer. So that means the measure of arc BD is 40 degrees. Okay? Now the next page is just more practice for you. So you could try these. You know, I'd pause the video, try the problems out, but I'm gonna do them so this way you have them to look at. Okay, so here the next problem is you have to draw the diagram, so you need a circle, and you're gonna have two tangents that meet at point P. So these tangents meet here at point P, and it says the major arc is 200, and we want to find the measure of angle P. Now you might say there's not enough information here, but we saw this before. If you do 360 minus 200, you get that this inner arc has to be 160. Now that's not the answer. That's not what you want. You want the measure of angle P, but that's okay because the measure of angle P is equal to the major arc minus the minor arc over 2. So x equals 200 minus 160 over 2. X equals, that's 40 over 2 is 20. The measure of angle P is 20 degrees. All right, try this problem, then pause the video, and then you can check my answer. Okay, arc KM is 94. Angle P is 24. And we want to find arc LN. So here we want to do the outer arc minus the inner arc divided by 2 is equal to the angle. I'm not going to write the formula here. I'm just going to give you the answer, or the setup formula. The angle is equal to the bigger, further away arc from the angle minus the closer arc divided by 2. Put this over 1 so you could cross multiply that. You get 48 equals 94 minus x. Again, here's another nice situation where you subtract 94 and you're going to get a negative number, but that's okay because x was also negative, and if you divide by -1, you get x is 46. The measure of arc LN is 46 degrees. Okay? Okay, last problem. Again, pause the video, try it out, and you can check my answer. Okay, arc AC is 80. Oh, this one's a harder one. Arc AC is 80. Arc AB is 90. Arc CD is 130. And we want to find the measure of angle P. Now, they gave us a lot of information here that doesn't appear that we need. But that information will come in very handy. Now watch. Technically, we don't need that arc or that arc. We just need the arcs on the inside. This 80 and that arc. But there must be a reason why they gave us this extra information. And the reason is, we don't know the measure of this arc. And there's not enough information to figure it out just by using one of those formulas. What we're going to need to do is we're going to have to recognize that there are 4 arcs making up this circle. You know 3 out of the 4. Let's add those together. If you add all those arcs together, that gives you 300. And if you take 300 away from 360, we now know that arc BD is 60 degrees. So now we know the 2 key pieces of information. I'm going to circle them with a blue pen. Those are the arcs we care about, not the 90 and 130. Remember, we need to work with inside this angle. So that 90-degree angle is irrelevant, and this 130-degree angle is irrelevant. We need the arcs inside that angle. And now we're just going to do the bigger arc minus the smaller arc divided by 2. So the angle is equal to the bigger arc minus the smaller arc divided by 2. 20 over 2 is 10. So the measure of angle P equals 10 degrees. Okay? So that's how to do this lesson. Hopefully it was okay for you.